Nothing should be more organized than preparing for the kingdom's attack. Everyone should be in the right place to defend the city. We have the same thing here in coding, which is object-oriented programming. How do we link OOP with a kingdom under attack? When we have different fighters, many enemies, and a battle about to begin. That's what we will see in today's episode. We have no time, we must be prepared. You have probably heard of OOP, Object-Oriented Programming, a paradigm supported by many programming languages. Your project is built using classes, the blueprints or templates, and from those we create objects, which are actual instances of the class. So what does a class have? In my OOP Kingdom project, which you can find on GitHub, linked in the bio, I demonstrate all the core OOP concepts. Each class has attributes like the soldier's name, power or health, behavior, the soldier's actions represented by methods. Let's look at our base class, Kingdom Army. Every type of soldier inherits from this base class, like Golden Knight, Knight, and even Squire, who is a grandchild of Kingdom Army. But it's not enough to create classes, we need to link them together. That's where the three core principles of OOP come in: encapsulation, inheritance, polymorphism. First, we start with encapsulation. As the name suggests, it's like a capsule. When you take medicine, you don't access their inner ingredients directly. Similarly, a class should hide its internal state, its attributes, by making them private. So how can we access private fields like health or name? We use getters and setters, which give us controlled access. For example, you can prevent setting health to a negative value through a setter. And depending on your design, you can use other access modifiers like protected, default, or public to allow or restrict access from outside classes. Second, inheritance. The Kingdom Army class is the base class for all the soldiers. Why? Because Golden Knights and Knights share common traits like name, power, and attack enemy method. They inherit those from the parent class. So you can say a Golden Knight is a Kingdom Army, a Squire is a Knight, and also a Kingdom Army, indirectly. This is a relationship, which is the heart of the inheritance. Talking about relationships, we have another kind has-a relationships: association, aggregation, and composition. Besides inheritance, there is another important concept in OOP, has-a relationships. They are not about being the same type, but one object using or containing another one. First, association. Two classes are linked but neither own the other. For example, a Kingdom Army object uses a battle level object during the fight. In code, we have setBattle method in the Kingdom Army class that receives a battle level object as a parameter. This is association, a loose connection. Second, aggregation. This is soft ownership. For example, the inventory object is created outside the Kingdom Army and passed into it through the constructor. If the army dies, the inventory could still exist and be used elsewhere. That's aggregation. Third, composition. This is strong ownership. In Kingdom Army, we create a list of sword objects inside the class constructor. When the army object is destroyed, the swords go with it. That's composition. So you can think of a soldier joining a battle. If one soldier leaves, the battle still goes on. Just like a soldier accessing a shared inventory system using their ID. The inventory is not destroyed with them. It's shared across the system. And finally, a knight is never without his sword. The sword lives and dies with him. It's part of who he is. Now let's talk about polymorphism. Polymorphism means many forms. Let's say we define an attack method in the parent class Kingdom Army as an abstract method. Each child class Golden Knight, Knight, and Squire overrides this method to perform a specific attack. So we can call attack method through Golden Knight object, Java will call the Golden Knights version of attack, not the one in the parent. That's called runtime polymorphism or dynamic method dispatch. There is also method overloading, where a class defines multiple methods with the same name, but different parameters. And overloading is resolved at compile time. Let's play with it in the main function. We create characters using upcasting, where the reference is the parent but the object is the child. It will call the knight's version of attack, but can't access any child-specific methods. It can access only the parent part in the child. But what if we want to use a child-specific method, like train squire? Then we use downcasting. We are telling Java, I know this is a squire, let me access the special stuff. And just like that, by organizing our code like a kingdom, with powerful relationships and clean rules, we can build scalable, testable, and maintainable software. It's more than just syntax. It is a mindset behind every repository system. Thanks for defending the OOP kingdom with me today. I have left enemy base class for you to build it with me. Also, I'm thinking to make it a real battle and complete the full project. Any thoughts? Happy to know it. Share yours in the comments below. If you like this breakdown, check the full code in my GitHub and subscribe for more episodes. Long live clean code!